Here's a question where you are asked to graph this quadratic function. Okay, so to graph it, what we need to do is find out information about it. Specifically, they want to know the vertex, line of symmetry, and whether it has a maximum or minimum value, and what that value would be. You can also look for x-intercepts and y-intercepts and other information, but this is all they want to know. Now, if this is what they want to know, probably the nicest way or easiest way to do this is to change this equation so it looks like this general vertex version of the quadratic formula or quadratic equation. So I'm going to just write this right underneath there. I've got f of x is equal to 5 minus x squared. So I have to make this look like that. Well, and it looks like the order's funny, so let me just change that. So it'd be minus x squared plus 5. Looks like now I've got this thing sort of figured, but I don't have this looking exactly the same as that. So I'm thinking k is 5. I could probably put that in right there now. But I need to figure out this first part. Maybe if I were to rewrite it like this. So I'd have a minus out front, and then I'd have a bracket, I'd have an x, but there's no other number beside that. So I guess I could write a 0, because subtracting or adding a 0 doesn't affect x squared plus 5. So now I've got the equation that looks like this one. A couple things to note. First would be my vertex. It'd be 0 and 5, because the equation or the vertex point coordinate is whatever h and k is. So my vertex is at 0 and 5. Line of symmetry is always whatever h is. So it's x is equal to 0. The maximum value is always whatever y is. But I don't know if it's going to be a maximum or a minimum value. To find that out, I go and look at whatever a is. And in the Scribblecast and in class, we talked about if a is positive, or in other words, it's greater than 0, the parabola will look like this. But if a is less than 0, then the parabola is going to look like that. We also talked about if it was 2 or 3 and how the graph might be skinnier or real wider. So we talked about that if the number gets 2, 3, 4, 5, etc. But if it's positive, it looks like this. If it's negative, it looks like that. We have a negative, so it must go like this. So this must be the one that I'm going to have. If I have one of these, then this is going to have a maximum y value of a certain number. And in this case, it's positive 5. So it's a maximum value of 5. So let's graph it. 0, 5, 0, 5. There's my dot right there. And it has to come down from there. And so it's going to come something like that. Now, I guess I could keep going. But I'm going through the x-axis here in spots where, yeah, I'm just guessing. Because I guess I could see if what these actual numbers are. So I could do a table of values and say, well, if x is 2, what does y come out to be? So if I put a 2 in there, 2 squared is 4, 5 minus 4 is 1. So to value an x value of 2, y value is 1. So my graph looks like it's a little wide. Let me erase it. So I've got an x value there, and I'm probably going to have an analogous one over here. Here's my top point, so it's going to come down something like that. Okay, hopefully that gives you a hand with that particular question and graphing and finding some characteristics of that quadratic function.